Hi guys, my name is Richard and welcome back to the RQ studio. Now today in this video, we'll be covering the most commonly used SQL commands, including DDL for creating tables and DML for inserting, updating and deleting data. So for those of us that are new to this, DDL stands for data definition languages, and these are used for creating databases and tables, whereas DML focuses on the manipulation of the data that exists within the database. And so we'll dive right into it. I must add that this video is actually the first in a series of SQL tutorials where I will be teaching SQL from basics all the way to the advanced level. This series is designed for beginners who are just starting out, as well as intermediate users who want to sharpen their SQL skills and move towards an expert level. So if you're interested in learning SQL properly and building a strong foundation and growing your confidence step by step, make sure you stay tuned for the next videos in this series. So let's dive right in. Okay, so the first step is to create a database. Now I already have a database created, and so we are going to call out the database that we have created, making use of the use function in SQL. So my database, as you can see from the left hand side, is DummyDB. So I'm going to type use DummyDB. Now note that once I started typing, the text DummyDB was suggested, it popped up. So that's a feature of SQL Server, and depending on the database you are using, you may get suggestions. If not, you would have to write the entire SQL script. So I'm using Microsoft SQL Server, so let's keep moving. So I'm going to click on use DB and then click on execute or run. I like to give comments for every SQL script. It allows me to structure my SQL scripts well, and also allows for easy understanding of the script I've written for later. The text in green, hyphen, creating a table, serves as notes. They are not actual scripts, they are just notes. And everything else is going to be an SQL script. Create table. And we are going to name the table micro schools. Micro_schools. So once you start the SQL script by writing create table, you input the table name, that's micro schools, and then you input the columns you want to exist in that table and also the data types for each column. So the first table I'm creating, the first column I would like to create is going to be called first name. And the data type is going to be text. In SQL Server, that's nvarchar. And the number of characters I'm assuming will be the maximum I'll use in that column is going to be 50 characters. So hence the 50 in the between the brackets. I'm going to put a comma there and then move to the next line. The next column is last name, also text or nvarchar, 50. Now my age, I'm going to create an age column and I want it to be number. And so the data type for the age column is going to be int. And then finally, a class column, also going to be text. So I'm going to end by closing the brackets. So notice that we started by having a bracket open after we typed in the table name, and then we also have to have a bracket that closes out at the bottom. So now I'm going to highlight the entire script and run it. So in SQL, you have to highlight the scripts and run them, or you can run all scripts on the page. We want to preview what we have done. So let's look at the quick preview. So my next script is going to be for previewing tables. Select all from micro school. I'm going to highlight that, click execute, and there you have it. I've created a table that has 4 columns. first name, last name, age, and class. So that is there. However, we don't have any data in the table. So that's going to be our next step. We are going to be inputting data into this table. This is going to, or my note is going to be insert table. And then I'm going to use the insert into SQL function. So I'll type insert into micro school. That's the name of our created table. And I have to state the columns that I want to insert into. So in the brackets, I'm going to state first name, last name, age, and class as the columns that I want to insert into. Values, meaning that the exact item I want to insert into these columns fall under values. So for the first name, I want to put the name Kwame there. For last name, I want to put Zanke, age 21, and class, let's say A1. And I like to pause here and just note that anytime you are inputting text data, it has to fall within the inverted commas. So that's how come they are in red. Anything that's text or anything that falls within inverted commas is seen as red in SQL Server. So first name column is in red, last name is in red, age is a number column. So number column you do not put in inverted commas, and then finally class is also a text column, so it's going to be inverted commas. You close your bracket, and now we can run this script. And one row has been affected. Great. So we are going to preview the table. And from our preview, we can see that one row has been added to the table. Row 1. Great. Now, you can choose to insert more than one record at a time. And I'm just going to demonstrate that. Insert into micro schools, values. So I'm going to enter these 3 rows into the table. So I'll just highlight the text and execute. And you can see from the message 3 rows have been affected. So in order to see our output, we'll just preview the table. And now we have 4 rows. So note that on the far left hand side, numbers appear beside the columns. These are like indexes just to let you know the number of rows within the table. Also on the far bottom right hand corner, you can see 4 rows at the bottom, and that's just to show you the total number of rows that are available in the table. So keep your eyes focused on the far right corner to be able to determine the count of rows within any table that you create. Our next step would be to update a table. And so with the records that we have inputted into this table, we're going to take one and we're going to update the records. So update table. And I'm going to change the last name of Jackson Hardy. And I'm going to change the name from Hardy to Love. So the SQL script for that is update micro school, set last name as set last name equal to Love, where first name equals Jackson. So this is an update statement that has a condition. So the where clause serves as a condition. I'm going to execute that, and we realize that Jackson's last name has been changed from Hardy to Love. Great. So we have successfully updated the table. Now I'd like to add that I'll be creating more videos on select statements and how to query data, so watch out for that. In those videos, we'll dive into there's so many different conditions that exist in SQL. So Watch out for my next video. And finally, let's move on to deleting a table. So I identified that I have 2 rows. So you saw me run the scripts, and so I intentionally created a duplicate, right? And the duplicate was Kwame Zanke, right? So we now have 5 rows instead of 4. And now I want to delete rows within the table. So you can delete a single row or more than one. So I want to delete the record Kwame Zanke completely from the table. So I'm going to type delete from micro school and then add a condition. So the condition, the where clause is what is used to determine conditions. So where last name is equals to, don't forget your inverted commas, Zanke, highlight and execute, and then preview. Great. So we realize that Zanke, or the 5th row, is no longer existing in the table. Therefore, we have successfully deleted the record from the table. So that's all for this video. So before we go, I'd just like to add how to delete a table. We started this video with how to create a table, so I'm just going to end it this way. So I'll just enter my comment and then write the query. So the query is going to be drop table, and then you add the table name. In this instance is micro school, highlight and then execute. Now once you execute this query, the table you created has been deleted from the database. So even though you may see the name of the table in the database on the left hand, after restarting or refreshing, it won't be there. And if you run the select all for that table in particular, you're going to get an error. In the previous video, we learned about DDL and DML. And in this video, we are going to be learning about DQL. Now, I'm sure you'll be wondering, what are these terms? DQL stands for data query languages. Now, data query languages is the ability to query a database to retrieve data without updating the data or changing the data that sits in the database or sits in the table. And that is the focus of this video. So stay tuned. So I'll be taking you through select statements, queries for filtering data, queries for sorting data, and finally, queries for aggregating and summarizing data. So let's dive right in. For the purpose of this video, I have created a database called OnlineDB, and I've uploaded a table in it. So when you look on the left hand side, you see that I have 2 databases, WDB and OnlineDB. And when I expand the OnlineDB and go to tables, you see that I have a table called Online Retail in that. So that consists of a data set that I got online, a dummy data set, and that's what we'll be using for the entire SQL tutorial. So I'll share this data with you in case anyone viewing wants to try to write the SQL statements and go along with the video, they can do that. So watch out for the link to the data set in the description. The first thing we're going to do is we are going to call out the database, making use of the use function, use online DB. And we are going to execute that. In SQL Server, you need to highlight the query, click on execute, or press F5 or run, depending on the software you're using, be it SQL Server, MySQL, and the likes. But what I'm using for this video is Microsoft SQL Server. Right. So the first DQL script we are going to be writing is select statements. But I like to start by writing comments. So anytime you see the hyphen, 2 hyphens before some text, then it's a comment. So all comments will be seen in green. And I think it's a good practice when writing scripts to always add comments for easy traceability, easy readability, easy auditability, and allows you to review your script later on and easily understand or easily run through them to understand what you are trying to do in that moment. I mean, as you go along, as you travel on your journey in SQL, you realize that sometimes you refer to scripts you've already written as a reference, and comments really help a lot. So I'm using comments. Right. So what we are going to do is write the first select statement, or write the first query, and that's a select statement. So we'll make use of the syntax in SQL, which is the select, followed by, in English, we would use the term all, from, and then we would use the table name. So if, let's say, we're writing an English statement, this is what we intend to do. We intend to select all columns from the table. Just for explainability, I'm just using this as an example. So if this was English, or an English, if this was English, I would write this as a statement: select all columns from, then I put in the table name. Now in select statements, the term all is represented with the asterisk, right? So instead of all, the term, we make use of the symbol, the asterisk. So the select statement is going to go like this: select all from, then select the table name, and in this instance it's online retail DB. Luckily for us, SQL Server gives us suggestions when we start our SQL statement. So I'm going to highlight it and execute or run, and there you have it. You have run your first DQL statement or first query, and this allows you to review or retrieve data that sits in that database, specifically in the table that you have called out, right? So in the online DB database, there is a table called online retail, and in that table we have these columns. Okay. Now if you want to call out specific columns, let's say in the instance where there are so many columns in that table and you just want some specific columns for some analysis purposes, we are going to get through to that. So instead of writing select all, we'll take out the asterisk and put the specific column name there. So I'm just going to highlight this, put it right here, and I like to write select statements by putting the select on one line and the from on another line. But then, I mean, it's just preference. You can put everything on the same line. It's up to you. So I'm going to replace the asterisk with the column name. So I want to see description. We use comma to separate columns. So I'll just put a comma there and write the next column: quantity, units price, country. Right. So let's say I just want to see these 4 columns, right? I'll just get to write that, click on execute, and there you have it. We have 4 columns being previewed. So on the bottom of the preview, you see executing query. So because of the amount of data within the table, it was still running. So now you can see query executed successfully, and we have over 541,000 rows existing in that database, right? So now we have learned how to write a select statement, and we've learned how to pull out specific columns. So let me just add that in the comment section as select for specific columns. Now we are going to learn how to filter data. Now filtering data involves adding conditions to your SQL statement. So let's build up on this script that we have written. So I'm going to select this, go down, and on a new line, we are going to make use of the where clause, right? So where is the syntax that allows you to add a condition to your SQL statements. So I'll paste our script here and then add a where clause. So where imagine out of the data that we have, we want to focus or view data on a specific country. So in fact, instead of just these rows, I want to see the entire data set. So select all from online retail. And I want to see, I noticed that we have a country column, and I want to see online retail data for the country called Ghana, right? So where country, you call out the column equals. Now note that the country column is a text column, and so it has to be inverted commas. Also note that SQL Server is not case sensitive. So we have added our condition, and the condition is where country equals Ghana. So I'm just going to run that. Query executed successfully, and we have one row, and this shows that in our database we only have one row where the country equals Ghana, right? If I want to filter another country, I'll just change it to, let's say, Nigeria. Click on execute, and there you have it. We have a country, we have one column that's country equals to Nigeria. So the next thing we are going to look at is if you want to have multiple conditions in a single select statement or in a single query for retrieving data, right? So let me just run select all from online retail. Note that when I selected just the select all from online retail, I was able to execute it, not taking into consideration the condition. So that is possible in SQL. So let's say now I want to make use of, I want to add multiple conditions, and there, in order to do that, you can use what we call the end function, end. So let's say I want to write a select statement. Select all from online retail where country equals United Kingdom, and so we are adding the new syntax and quantity equals to 6. Now note that that is a number column, so we didn't put it in inverted commas. I'm going to highlight this script and run it, and you realize that the query has been filtered, and if you look at the total number of rows, we have 35,000 rows, and in the quantity column we have 6, and in the country column we have United Kingdom. So you can go through that and you realize that we have filtered exactly what we want to see. Let's say we don't want to see, we're not concerned with the exact country. We want to change country to unit price. So where unit price equals, let's use 10, and then run. Great. So realize that the table is empty, which means there is no product where the unit price is 10. Let me use 2, execute, and there you have it. We have filtered down our data to show us data or information where the quantity is 6 and the unit price is 2. So that's one way to filter with multiple conditions, and you make use of the end function for that. So conditions can be applied, this condition is applied whilst filtering. So let's say now we are going to move on to the next filter mechanism in SQL called the OR function, OR. So imagine I want to see information where the country is either Ghana or Nigeria. Let's write a query for that. Since we already have that in our where clause, I'm going to copy this and put it here, and I'm going to add OR to this statement. So OR country equals Ghana. So in this SQL statement, I'm saying that select all the rows within the online retail table where the country is equal to Ghana, or the country is equal to, where the country is equal to Nigeria, or the country is equal to Ghana. Execute. There we have two rows as our results. One row where the country is Ghana and the other where the country is Nigeria. So that's what the OR function does. Now I'd just like to add that the OR function is very useful, especially when you want to filter two different columns, right? So imagine I wanted to filter maybe where the country equals Nigeria, or instead of country, I'm going to say or quantity equals 5. I'm going to run that, and you note that in the quantity column we see 5 and we see a different country name, United Kingdom. So all countries where the quantity equals 5, or when Nigeria is the country, is represented in our results. We could change the OR to end, and if there is a country, if there is a record or row where the quantity is 5 and the country is Nigeria, it's going to give us exactly that. And so that's there you have it, and that's how to make use of the OR clause. The next filtering condition I'd like us to look at is in. So another way to filter a specific column, one specific column with multiple values, is to make use of the in clause. So again, I'm going to use the script we've already written and build on that. So here, instead of writing where country equals to Nigeria and where country equals to Ghana, I'm going to change the equal to in, put it in brackets, add Ghana, put a comma to separate the two, close the bracket, and then run this script. And there you have it. We have the exact same results when we run the first script, or the initial script, where country equals to Ghana and country equals to Nigeria. If we had done that, we would also get the exact same results, right? So let's just test that. Run this script. Change the syntax from end to or. There you have it. But you can run multiple scripts at the same time, honestly, if you select both of them. So imagine I select these two and run them. There you have it. Two tables on top of each other, showing the same results, written with different queries. So that's how to use the in and not in function. So imagine you want to filter out some specific countries. You want to see data on all countries with the exception of a specific country. So in English, we would say all except. However, in SQL, we would say not in or not. So let's look at these two clauses. So I'm going to again build on this script. Select all from online, where country not in United Kingdom. And what this script does is it's going to show me all other countries with the exception of United Kingdom. And with this, I can also add, let's say, I don't want to see France as well, not in France. I can add multiple conditions. Right. So you see Australia is there, Spain, Finland, and the rest. So I can keep adding so many different countries. And it's going to filter out these things as well. Also, with a not equal to function, not equal to works for a single item or single row or single unique value within a specific column. So let me just go down, copy paste this, and instead of not in, I'm going to make it not equal to. Sorry. So the not has to come before you call out the column. I intertwined the two, but then I've corrected that. So let's run this query. And from the results, you would see that United Kingdom isn't part of it, right? We have, our query executed successfully, and I've already gone through it. You can do that yourself if you're going along with the video and you realize that the country is not in the query statement. So the next query we are going to look at is between. So imagine you want to filter data in a table in a specific range, and this is largely used with the date column. Luckily for us, within this database, we have the invoice date column. And so we are going to write a query with the condition making use of the term between. And this is going to determine the range of values, right? The range within which sales were made. So let's look at that. Select all from online retail, where invoice date I'm just going to take this date format and so let's say invoice date between 1st January and 31st. So we have filtered, making use of the between condition to select a range. So the range that I have filtered is where the invoice date is between the 1st of January 2010 and the 31st of January 2010. And if we scroll through the data, you realize that all the dates are within January, right? Another way to confirm if you want to perform some analysis is you can easily copy the data within SQL in the results and paste it in Excel. So you can click on this box in the top left corner here to select the entire grid. You can copy with headers. You can go to Excel. Let me just empty this sheet and then paste your results here, right? So this is another way to cross-check your results. And also if you want to move or switch to Excel, especially when you have been able to filter or narrow down your data to a range that will fit in Excel, you can come and perform your analysis here. This is just by the way. So back to SQL. Okay. So that's how the between function is used. It's used to select a range of data. So when you want to retrieve data from the table, the between function is very, very useful. The next function we will be looking at is like. So the like condition is for pattern matching, right? And this allows you to select or search for information based on specific keywords. So let me just demonstrate. Like, put this there, select all from online retail, where let's use the description as our test. So where description like. So what I want to tell SQL, or what I'm telling SQL in my script, is I want to search for any data within the table in the description column that ends with bag. And you tell it, so the percentage sign before the text at the end is what tells or what determines the value you're looking for and where it is positioned, right? So I'm going to run this, execute. And from our results, you note that each and every single description here ends with bag. So bag, strawberry shallot bag, skull shoulder bag, strawberry shopper bag, shallot bag, and the likes. So all the results end with bag. So imagine, let's say you have a description column that has so much information, and then you know one keyword that can help narrow down your search. The like function is very important and very valuable to help filter down your data. Imagine the word you're looking for is at the beginning. Let's say the word you're looking for is strawberry. I'm going to change the text to strawberry, and I'm going to move this percentage sign to the end. And also take note that since we are dealing with a text column, and that is why it is in inverted commas. I'm going to highlight this, run it, and from our description column and from our results, you realize that each and every single record starts with strawberry. If I'm to scroll, right, strawberry throughout. Now imagine if you don't know whether the word is at the beginning or the end. Example, let's use the word bath. From row 9, you can see that we have strawberry bath sponge, right? So I'm going to change the word here to bath, put a percentage sign at the beginning and the end, which means that the word falls within the range of the description. So I'm going to highlight that, execute. And from our results, you will note that bath is found in each and every single row, not necessarily in the middle. As you can see from the first row, bath starts the description. As you can see from other rows, bath can be found in the last word and the likes. So the like function is also very pivotal or very important when you want to filter specific columns and the column consists of a lot of information. So that is what the like function is used for. The next query we are going to look at is the null function. Is null. Now what does this mean? So this is where you want to filter out specific rows in a table where the column has empty values. So usually SQL represents empty columns with the word null, N-U-L-L, right? So you can also call out that. So even at a glance at our data, you can tell from the customer ID column that there are some null values there. So as part of, let's say, your data exploration, you want to check specific columns, you can do that. So let's add the is now condition and see how it works. I'm going to copy this, paste, select all from online where customer ID is null. So we've been able to filter that, and that this gives us an idea of the fact that the customer ID is not complete. Some customers have no IDs within that column, and this allows you to focus on this information in order to either investigate further to gain the customer ID or address it. We can also tell that there are some null in the description column. So we can also change the condition from customer ID to description is null. There you have it. You can also check invoice number, and it will work on any column as long as there are some null values. Right, so with the invoice number, note that no data was showing. This means that there is a value for the invoice number column, right? It means that each and every single row within the invoice number column is not empty, and that's what it means. And now this brings us to the next function. Imagine you want to focus on only data that has values within it. The next filter query is there is not now clause. So I'm just going to highlight this, copy, paste, and just add the text not. So what I'm saying is select all columns within the online table where invoice number is not null. Highlight, execute, and it shows you that. So once you go through the data, you realize that there are no null values. Right. So these are all columns, or these are all conditions within SQL DQL language, data query language, for retrieving data. And most times databases keep large volumes of data, and the challenge that we usually have is how to work our way through that data, how to filter that data. And that is why DQL exists, to allow us to easily filter out the data that we have, and perhaps even switch platforms to engage in further analysis. So from here, once you know how to write these scripts, you know how to query to retrieve data, you can now, let's say, connect it to Microsoft Power BI to visualize your results. You can copy the information you have here and paste it in Excel, perform some analysis on it. And these are some of the few conditions that are used to filter data within SQL, right? So I want to take us through how to summarize data. Before we summarize, I just want to show us the distinct function. Yeah, so I'm going to do both of them. So let me just start with select distinct from online retail. So let's say select distinct country from online retail. I'm sure you've guessed what this script is going to do. It allows you to get the unique values that exist within that column. Right. So if I run this, my results show 40 rows. And these 40 rows show that within the country column, we have about 40 different countries, from Finland to USA to Germany and the likes. 40 different unique countries exist within the column. And that's what the distinct function does. It allows you to select unique values within the table. Before we move on to the order by and group by function, I just want to show you some aggregation queries, and that is the count. So imagine I want to count how many times each country appears, right? But let me just start with the regular select statement. Take it one step at a time. So once you write a select statement like this, where I've written select all, I can add an aggregated column to it by adding a comma and then stating my aggregated column. And in this instance, I want a count, right? So I'm going to type in count, and in the bracket put count all, run this query. And I have gotten an error. Why? Because in order to count information, right, you need to sort of group it or summarize that information. So just as within Excel, a pivot table would work, it only works by summarizing the data that exists. We need to also summarize the data within SQL Server, and that's what the group by function is used for. So instead of writing select all, I want to summarize or count the amount of times countries appear in the rows. So I'm going to edit or update my script to select distinct country, comma, count from online retail. And in order to summarize it, the syntax or SQL clause that is used is the group by function. The group by function is what is used for summarizing data within SQL Server. So I'm going to add that as a condition. So select distinct country, comma, count all from online retail, group by country. So in the group by function, you need to state the column that you want to group by, and usually it is the column that you have stated in your select statement. So I'll highlight this, execute, and there you have it. We have successfully written a script and executed a script for group by. Now imagine, so you note that the result has a column header for the countries, but no column header for the count. In order to add a column header, you need to make use of what we call aliases. An alias, right? So this allows you to add a column name to an aggregation that you've done. So let's say you've summarized, you've counted a column and you want to name that column count. That is what we call alias. So I'm going to edit my group by query and just put here as count. Execute. So the alias works by allowing you to give your aggregation a name. So you can see from my results that now the count column has a name and I named it count. I could have changed the name to count countries. And that is exactly what it's going to show me. So looking at the results, you realize that there's no order to the count. So if you want to sort out a table in SQL, the function that is used to sort tables or sort out data is called the order by function. It allows you to order data in ascending order or descending order. Now, by default, the order by function is in ascending order, and you would have to state whether descending order or not. Yeah. So I'm going to continue to build on this group by function. And add another condition called order by. And I want to order by count of countries, right? And that is the name that I gave it. So note that even in the suggestions, we have count countries there. So if I'm to run this, it is automatically going to order or sort out my results in ascending order according to the count column. from the lowest to the highest. And there you have it. So Nigeria and Ghana appear just once, Saudi Arabia appears 10 times. If you want to order in descending order, you have to add DESC for descending order after you name the column you want to order by. Let's rerun this. Right, now we started performing some analysis in SQL. So from the use of distinct, use of the group by function, use of the aggregation function, which is count, making use of the order by function, we have been able to summarize data according to country, and we can tell at a glance from our results that the United Kingdom appears the most within the table, whereas Ghana and Nigeria appear the least, right? And so these are the count values. Let's say you want to even multiply columns, total sale. You can make use of the aggregation of multiplication as well. So let me just demonstrate that as well. Multiplication. So let me just select all. This shows you all the data in the table. And note that we have a quantity column and a unit price column, but we don't have a total sale column. So imagine you want to add a total sale column to this query, right? Note that adding it serves as a temporary table. It is not, you are not necessarily adding to the database itself, but you are adding an aggregation that is a temporal table simply because you've run your query. It's not a data definition language that is going to alter the database, right? These are data query language, and in fact I'm even moving into data manipulation languages, right? So in addition to the select all, I'm going to add a column called total sale, and it's going to be the product of quantity times unit price. I know it can be confusing. I'm still using asterisks. So in this instance, you have to put it in a bracket in order to ensure that the asterisk means multiply. So I'm going to run this. And we can already see that in addition to all the columns that exist in the table, we have a new column with no column name, which has values. So you can see 15.3, and if you multiply 2.55 by 6, you're going to get that. You can check, and same for all the rows. Now we want this column to be named total sale. So I'm going to go back and update my query as total sale. Note that when you're writing column names, if you want to have space within your column name, make sure you put the text in inverted commas. So I execute. Column name is sent to total sale. I can take out the hyphen there and rather put this in inverted commas and run. There you have it. Right. So that is how to group by, that's how to order by, that's how to aggregate information as well, right? The next query for aggregation that we are going to look at is the having function. So we have a group by function that allows you to summarize data according to the rows. But then imagine you want to summarize your information and still perform some aggregation. You would now make use of the having function. The having function's purpose is to filter aggregated results, right? So I'm going to build on the group by function and put it here. What we're working is with the having function. So select all from group by. Then we add the function having count. So imagine what I want to do is I want to limit the count. I want to see countries where the count is more than 2,000, right? So that is where the having function comes in. So having counts or counts countries greater than 2,000. Sorry, so SQL does not understand the alias I've used in the having function. So I'm going to select the actual aggregation, which is count all, and use that in the having function instead of the count countries. Because SQL does not see count countries as an actual column that exists within the table. That's how come we are having or getting that error. So just click on execute. And there you have it. The count of the countries has been limited to 8 rows, and each of the rows within the data is above 2,000. Can order this again. Counts, countries. So I've ordered our results in ascending order, and you can see at a glance that Switzerland has the least count of the 8, right? These are ways of applying conditions to select statements to retrieve information and perform some analysis on it. So watch out for my next video where we'll dive deeper into SQL scripts. In this video, we are going to be learning about joins. I'm sure some of you may be wondering what joins are. So imagine you want to connect two tables together in order to be able to analyze data, or pick one data from one table and compare it against another table based on a unique identifier, maybe an ID column and such. In Excel, you would have made use of the XLOOKUP function or the VLOOKUP function. However, in SQL, you will make use of joins. There are different kinds of joins. We have the inner join, the left join, the right join, and the full outer join. And that is what we will be learning about in this video. So let's dive right in. So in my dummy database, I have uploaded 2 sample tables that we are going to be using for demonstration purposes to understand joins. We have the customer table, and we also have the customer sample and the order sample, right? So I have already executed to run my dummy DB, and I'll just preview the tables so we know what data exists in them. So the customer table, in the customer table, we have 4 rows of data and 3 columns. We have the customer ID column, the customer name, and then the country. Now in the orders table, we have the order ID, the customer ID, and the order amount. Now comparing these 2 tables, I'm just going to run these 2 queries. So at a glance, we can tell that the unique identifier between these 2 tables is the customer ID. Now you can see that there are 2 IDs that can be found in the customer table that have placed orders, and hence they can be found in the orders table, right? And these orders are in the form of 3 rows of transactions, right? So imagine I want to generate a report that gives me the name of the customer, and the order ID and the order amount for the customer. I would make use of joins to generate that information. Right. So I'm going to start by demonstrating how to make use of an inner join. And this is the format the inner join takes. Select from inner join on. So like this is a standard format that, or these are certain syntaxes that are used in order to pull out the information you want. We know about select and from. Selecting is selecting the column, and from you have to add the table name. Now we are now going to add what we want to match this table to and what columns we are going to match them based on. Right. So I'm going to put the first table name here, which is customer sample. And I want that the customer sample table to be joined to the orders table, order sample. And I want this customer sample to be joined to the order sample on the unique identifier, which is customer ID. So I'm going to call out the customer table. So customer sample dot customer ID, equals to order sample dot customer ID. And I just want to see all from both tables, right? So I'm just going to put it all there. Let's run this query and see what happens. Right. So in running this table, in running this query, the results we see is all the data in the customer table that also exists in the orders ID table. And from the view of the order sample table, we could tell that there were only 2 customers that placed an order, right? Looking at the results, we can see that the customer ID, customer name, and country are coming from the customer sample table, and the order ID, customer ID, and order amount are coming from the orders table. Now note that the other customers with the customer ID 2 and 4 do not exist in this join, right? So that's how the inner join works. It allows you to match rows that exist in 2 different tables. Now think of it as the overlapping point of a Venn diagram, where you have table A on the left hand, table B on the right hand, and then in the middle is the overlapping point where data exists in between the 2 tables, and that is the inner version or the inner point. So that is the data that the inner join would present once you run the syntax. Now I want to simplify the look of this query for easy readability. In my previous video, I made use of alias to represent an aggregated column or column that I just created. With the use of joins, I'm going to use an alias to represent the tables. So with the customer sample table, I'm going to add a letter A. So A represents customer sample, B represents the order sample, right? And I'm going to change this entire code to this. So A dot customer ID, and you can tell when I started writing when I typed in A, the columns that fall in the customer sample table showed up. Once you put in the dot, then you can easily select that. Then same for B, right? So once I run this and execute, I'll get the same results. If I wanted to select specific columns, so let's say I just wanted the customer name from the customer table and the order amount from the orders table, I would type it in this way. So A dot customer name and b dot customer b dot order amount. So I run this query, click on execute, and there we have the results we are expecting, which is just the customer name and the order name. So this is how the inner join works. It's giving us the data that exists in both tables that match based on the customer ID. That is the unique column that serves as the link between the two tables. Right. So now we are going to demonstrate how to perform a left join. Now a left join is used where you want to combine two tables by keeping all the rows from the left table and only matching rows from the right table. So I'm just going to show you why it's called a left join. So let me just duplicate this query and edit it. So left join. So I want to see all columns that exist in both tables. That's why I'm using the all. And looking at this, the third line, inner join order sample on customer ID, a dot customer ID equals b dot customer ID. Okay, sorry, looking at it in this format, looking at line 2 with from customer sample A, inner join order sample B, you can see that customer sample or the customer samples table falls on the left hand side of the join, whereas the order sample falls on the right hand side of the join. Right, so with the left join, we want to see every record that exists in the table on the left hand side. In this case, that's the customer sample, and matching rows from the order sample table. Right, so I'm going to change the inner text to left, and run this script. So from our results, you can tell that we have all the data in the customers table that can be seen in the first 3 columns. And we can see matching data from the orders table. So data that does not exist in the orders table is represented with a text null, meaning empty, or there's nothing there or missing values, right? And this is how to perform a left join that allows you to see what is in the left table and matching rows in the right table. Right. Now, the right join is a mirror image of the left join. It's the opposite. If you want to see all data in the right table and matching data in the left table, that's exactly what you'd use a right join for. But mostly, we mainly use the inner join and the left join, right? But let me just demonstrate that. Now, since we are making use of the orders table and the customer table, ultimately all customers would exist in the customers table. So once I perform a right join, we are going to get results similar to the inner join. Right. So I execute it, and as you can see, all the data that matches, all the data in the right table, that is the orders table, and matching rows in the left table have been represented. And this is quite similar to when we run the inner join. Now this is based on the sample data that I'm using, right? Now we are going to finally learn about a full outer join, right? So a full outer join gives you all data that exists in both tables, right? So if you want to see all data that exists in both tables, we have a full outer join for that. And that is a function of the full outer join. However, the results may seem quite similar to what you see in the left join, but let's try it and see. So copy paste this code. script and replace the right join with full outer join. Run, execute. Let me take the full out, run, execute, and see. It didn't work. Great. So with a full outer join, we can see both all data that exists in both tables, and this was quite similar to showing all the data in the left table and matching rows in the right table, because based on the kind of data that we are using, one is a subset of the other, right? Great. So that is how to make use of the inner join, left join, and right join, and full join. And this comes in handy when you're analyzing data from two different sources, especially when they have a unique identifier or a unique value. You can easily use an XLOOKUP or VLOOKUP for that in Excel. However, when data gets so large that it can't fit into an Excel sheet, and you have to now analyze that data with SQL, joins come in handy, especially when you're dealing with millions of rows of transactions, right? So it's something that I believe that you need to know in SQL, right? And finally, as a bonus, I'm going to demonstrate how to perform a self join. Yes, it's possible to join a table to itself. So let me just give an example. Let's say you have a name column in the customer table, right? And some of the customers perhaps are also employees of the company that's selling the product. So yeah, they are customers and they are also, let's say, agents, sales agents, right? So perhaps you want to perform some analysis on that and you want to reference one column with itself. You can perform a self join, and a self join is quite similar to most of the joins that we have created. It's the same syntax, nothing changes, just that table A is going to be customer sample and table B is also going to be customer sample, right? So if I run this query, it's executed successfully, right? And you can see that we have 3 columns in table A and also 3 columns in table B. Perhaps I want to represent the customer name twice and give it different names. I'm going to say A dot customer name, and B the customer name as sales agents. Run this. Right, and the exact same column, I've represented it twice and changed one name to sales agent name. And this comes in handy when you want to, analyze a specific column or break the column down. Now, along the line in this tutorial, I'm going to be teaching us about Windows function. And Windows function is another alternative that allows you to perform data in a table by breaking it down to the granular level. So I've uploaded some dummy data set into the dummy DB again. This time our table is named the online retail on clean data set, and it's a subset of the data I used in part 2 of this series of SQL 0 to Hero. So I'm just going to call out the database and it will preview the data. Right. So with the data that we have, the first SQL function I'd like us to look at that comes in handy, especially when you're cleaning data and performing some data exploration, is the learn function. So I'm just going to write some notes for each query as headings. So every text you see in green that starts with 2 hyphens serves as a note. It's a good practice to always add notes to your queries to make them clean and easily readable and auditable. So len, and the len function is used to count the number of characters in a column. So a len function is also used in Microsoft Excel, and I'm going to show you how it's used here. So let's count the country column. And instead of previewing everything, I'm just going to preview the country column. Run this script. Great. Now I want another column beside it that shows the count of characters that exist within this column. So I'm going to add comma, len, put country again. And I'll name this column count of country. Run. Okay. So as you can see, there are 14 characters for the United Kingdom, 6 for France, 5 for Ghana, 7 for Nigeria. So this function comes in handy when you want to ensure that each and every single character, there's no spaces that exist within that column, right? So let's say if there were some spaces before or after the text, you would see more than 14 characters for United Kingdom. And this allows you to focus on that and then make use of the next SQL query, which is trim. So the trim function removes spaces, and this is how it works. So I'm just going to perform a lot of copy and paste because we'll be making use of the same script and just updating and editing it, right? So imagine we still have the country column and it has spaces in it, and I want a new column without spaces. So bear in mind, with SQL, if your data sits in a database and let's say you don't want to touch the data from source, but then you just want to run your scripts for perhaps some ad hoc analysis and such, this allows you to do that without editing the data that actually sits in the database. It creates temporal tables that only exist when the query is run. When these queries are not run, the transformations you are performing would not show in the actual data. So that's how it works. So with trim, I'm going to put the country in the brackets and name this column as trimmed country. Execute. Great. And so ideally, the trimmed country column will not have any spaces. However, sometimes the software that you use may automatically take out spaces. So if you're lucky like me, you wouldn't have to make use of the trim function. So let's go to our next function, which is upper and lower. So the upper and lower function is used to standardize text within a column. So notice, I'm sure you have noticed that the country column has both small letters and capital letters within it. So let's say you want to ensure that everything in the column has capital letters. This is how you go about it. Select all. Country. Upper country. Let's name this as capital. Run. And there you have it. Each and every single character within the country column, or each and every single word has been capitalized. So that's how it works. And the opposite is where you make use of the lower function and it gives you everything or transform everything to lower small letters. So that's how the upper and the lower function works. Now let's perform some aggregations. So looking at the data that we have, right? Let me just preview everything. We have a quantity column and a unit price column, but we don't have a total sale column, right? So if you want to perform some aggregation such as sum, multiplication, addition, You can do that with SQL, and I'm going to show you how to make use of perform some of those aggregations. So let's multiply the unit price by the quantity column to get a total sale column. And similarly, I'm going to sum up those two columns. So let's do that. So building on this script, I'm going to add a comma after the all, and then write quantity asterisk unit price. Now in this instance, asterisk stands for multiplication. So what I'm saying is multiply the quantity column by the unit price column, and let the column name be seen as total sale. When you're naming a column, it's best not to use spaces. It's best to use the underscore. But if you want space to be in between a compound name, you have to put it in inverted commas. Yeah. So I'm going to run this. And you can see that to the far right hand side, we have a total sale column. And you can perform your calculation. You realize that when you multiply the unit price by the quantity, you get the values in the total sale column. So that's one aggregation. Let's say I wanted a sum of that. I'll just take this, copy, paste, and change the syntax from asterisk to a plus, and name this column sum. Take out the comma at the end because we ended there. Execute. And when you scroll to the right, realize that the same two columns have been summed up to give you what we have in the sum column, right? So these are ways that you can perform aggregations in SQL. You can also look for greater than or less than. Let me just try that and let's see. So let's say you want to filter out the data where the quantity is less than 10. So select all from, and that falls under conditional statements. So select all columns from the table where quantity less than 10. Run the script. And we have 48 rows where the quantity is less than 10. And so these are some of the aggregations that you can perform in SQL. The next thing we're going to look at is the replace function. And the replace function works by, well, it is used to find a specific text within a column, and it replaces that text with another text. Right, so let's say in the description column, or let's say in the invoice date column, let me use the invoice date column. I want to replace the hyphen that separates the years from the months from the dates with a backslash. Let me show you how I'll go about it. So select from, let's see, select invoice date, comma, replace. So in the brackets, you have to state the column you want to work on and what exactly in the column you want to replace. You put that in inverted commas. In this instance, I want to replace the backslash, the hyphen with a backslash. So I'll put both of them in inverted commas, and I'm going to name this column new date. Run this, and we can see from a glance that now wherever you see a hyphen, it's replaced with a backslash, and that's how it works. You can use that on each and every single column within the database. So let's say looking at the stock code, I'm just going to change this and make use of the stock code column. Let's say when you look at the table, the first two rows have some letters there in the stock code columns, letter A. So I want to replace the letter A with letter B or letter Z. Let's replace it with letter Z as new stock code. So emphasizing on just those two rows, you can see that I've replaced letter A with letter Z, and that's what the replace function does. Now bear in mind, again, this does not change the original data that sits in the database. It only works when these queries are run. Yeah, and from that you can create views and choose to store those views as permanent. But then we'll be looking at views in my next video, so watch out for that. However, the next script or SQL script I want us to look at is the case function. So case or case when makes use of conditional logic. It works as an if statement, and if you have made use of if statements in Excel, you realize that if statements always have a condition. So this allows you to create a new column, a categorical column based on another column and based on conditions that you want to apply. So let's look at our data. And let's say, looking at the quantity column, we want to categorize this data according to customers. We want to categorize them as either a rich customer, an average customer, or a poor customer based on the quantities that they buy. So I want to write in a SQL that where a customer buys more than, where the quantity column is more than 30, then I want to see rich customer in the column. Where the quantity is greater than or equal to 20, I want to see average customer. And then finally, if it is less than that, I want to see poor customer, right? So greater than or equal to 30, greater than or equal to 20, and then if you don't fall in those two categories, poor customer. So let's write that script. So select from online retail, select all, comma, and I'm going to add that column in, that is our case column. So case when quantity is greater than or equal to 30, then rich customer when quantity is greater than or equal to 20, then average customer, else. So if you don't fall in these two categories, any other customer that buys a quantity that is not in these two categories and is less than that, I'm going to classify you as a poor customer. And then end this logic. And I want to name this as customer category. So it's customer category. So this is how the case when script is written. So let's run it and see. When you look to our right hand side, a new column has been added called customer category. That's what we just created. And you can see where the quantity is 6, poor customer. I scroll down, you can see some average customers and they have quantities of above 20. And the rich customer that has quantity of 48 and such. That's how the case query works. and it really comes in handy, especially when you want to group the data. It really helps with grouping data, so it's something to have at the back of your mind or have in your toolbox. The next thing I want us to look at is distinct. Now, how does distinct work? Now, distinct is a query that is used to preview only unique or distinct values within a column. So let's say we want to look at the country column, and note that when we run the script to view just country, because of the series of transactions, there are a lot of duplicates. But let's say we just want to see the total number of countries that exist in that column, right? I'm going to put the distinct function there, distinct, and name it as unique countries. And the result shows us 5 rows. So we have France, Ghana, Nigeria, United Kingdom, and United Kingdom in small letters. Because both of them, because they are not both in standardized, that's how come they appear as unique values. So this is what the distinct script does, and it really helps, especially when you want to summarize data. Let's say you want to see the total sum of quantities for each country. You would make use of a combination of scripts, the group by function and the distinct function. Let's see if I can demonstrate that. So country, comma, count of quantity as QTY count, group by distinct country, or group by country, let's run this, and we have managed to summarize the data, summarize the count of quantity for each country, and this is a combination of the distinct function and the group by function. You can even throw in the order by function if we are concerned with the order. Perhaps we want to order by the count and descend in order from highest to lowest. We can do that. And that's how the distinct function also works. So these are a few queries that we use or can be used in cleaning and transforming data. Also, if you want to look at missing values within a column, we have the is now function, and that is the next thing I'd like to look at. We have what we call is now, and we also have is not now. And as the name implies, we will be including a condition that allows us to see columns where we will be including a column. We will be including a condition that allows us to see columns that includes missing values or columns that do not have missing values. So select all from online where description column is null. That's how to write it. So you put the is null as a condition or as part of the condition. So in executing this, the results we see are all the columns or all the records that have the description as null. And if we want to see vice versa, we just put is not null there. And we have 67 rows. So that's how the is not null function works. And finally, if you want to replace these null values with with an actual value in order for you to easily summarize your data or perform some further analysis. You make use of what we call coalesce. Now this function helps to replace null values in a specific column. So let's see how it works. So you state the column you want to that has missing values and what you want to see in place of the missing values. So let's say I want to see the word empty. Let me run the script. And from the results, what we see is all the columns in the register, including a new column. And wherever you see null, you see the word empty. In fact, let me just show you the description column. You don't need to see every column. Great. So as you can see, wherever there's null, the word empty is there. And if not, every other thing is represented in that column. So that's how the coalesce function works. So these are a few queries that we can use in data cleaning and transformation. And they really come in handy when you're exploring and cleaning and transforming data. In addition to, we're moving into more powerful SQL concepts that help you write cleaner queries, reuse logic, and perform advanced analysis. So we'll be covering 4 important topics, namely subqueries, common table expressions, views, and Windows functions. They are widely used in real-world analytics, data engineering, reporting, and the likes, and I believe that mastering them will take your SQL skills to the next level. So let's dive right in. So we are going to be starting with subqueries, and I'm going to be making use of the dummy DB. DummyDB is the database that has some tables of data that I'll be using for this video. And the specific tables we are going to be making use of is the customer sample table and the order sample table. So let's preview those tables. Tables. So the customer sample has 4 rows. It has 3 columns, and that's the customer ID, customer name, and the country. The order sample table also has the order ID and has a customer ID in there and then the order amount. So you can see that customer ID is the unique identifier between the 2 tables, right? And so we are going to dive straight into making use of subqueries with this data set. So a lot of you might be wondering, what are subqueries? So subquery, simply put, is a query within a query. Do you get it? And this comes in handy when you start to write more complex SQL scripts. And I'm going to break down the various kinds or ways to make use of subqueries. So subqueries can be put in select statements. They can be put in the where clause and also in the from clause. So we are going to be looking at these 3 areas that subqueries can be put in and see how they work, starting with the select statements. So within select statements, subqueries are largely used when you want to perform some aggregation. So looking at the table, when we look at the orders table, we realize that the orders table has an order amount column. And let's say we want to find the average of the order amount, the average order amount from the orders table. We would make use of this query. Select average. Then you put in order amount from order sample. And when you run this query, we realize that the average amount is 233, right? So now we are going to put this query in another query. So let's look at that. We're going to put this query in a select statement. So it now becomes select all from order sample, comma. So what I'm saying is I want to see everything in the orders table and a subquery, which is going to be in these brackets. And what I want to see in the subquery is this script right here. And we'll name this column AVG amount. Run. Right, and there you have it. We have written our first SQL query with a subquery in it. So as the name explains, the subquery, that is the query within it, gives us a column once used in the select statement, because usually the select statement is used to pull out all columns in a table, or specific columns, or aggregated columns. In this instance, it's an aggregated column. So that's how subqueries within the select statement works, and it comes in handy as you move forward in your SQL journey. The next thing we're going to be looking at is subqueries in the where clause. So So I'm just going to write another SQL script. Select all from orders again, and then the condition where customer ID in. So from our preview, we identified that the customer ID is the unique identifier within the two tables, right? So I want to filter my data according to where the customer ID. I want to filter my table according to the country, where the country is Ghana, and the country column is found in the customer sample table. All right, so just look at how I write that. Select customer ID again from sample table where country equals Ghana. Right. And this is how it's going to look. Run it. And there you have it. So in our query, we have been able to filter out the orders table for specific orders where the country is Ghana, or orders for customers that are in Ghana. And that information we got in our subquery, it can only be taken from the customers table. And as you can see, it's working like a join, right? And so this is the power of subqueries and making use of it in the where clause. The next thing we're going to be looking at is subqueries in the from clause. But before we do that, I want us to create a summary table of the customer and orders, and then we'll put that in our from clause. So let's look at that. Summarize order and customer table by customer ID. So we're going to perform a join. Select from order sample as A, join customer sample as B on A.id equals B.id. And the columns I want to see are A dot customer ID, B dot, I want to see the customer name from the customer table, the country from the customer table, and then the sum of the order amount. So A dot order amount. And let's name this aggregation as sum of order amount. Group by. So I'm going to run the script, and there you have it. So I've been able to create a join that gives me information on both tables. And well, for this video, for this query, it's an inner join, right? So I want to see both the customer information as against the order amount. So now let's demonstrate how to put the subqueries in the from clause. So I'm just going to put this there, select from, and in the from, we're going to add a bracket, open, close bracket, and we are going to drop this script we have written in our from clause, and it's going to serve as our location. Let's name our location as summary table. And then state the columns we want to see. So I want to take customer name and sum of order amount from the table that we have created. So as you could see, the results from the summary table is what you can see here, and it includes the aggregated column. So right now, inputting this join in my from clause, I can pull out any column from that existing table here. So let me just run this script, and you see that the result is the same, just that in this instance I didn't want to see the other columns, the customer ID, customer name, and the likes, right? So that's basically how the subqueries in the from clause works, and it comes in handy a lot. With the from clause, you can pull out all columns or any column in the subquery that is in the from clause. However, with the where clause, you can only pull out one column at a time, right? And the next thing we are going to be looking at now is common table expressions, also known as CTEs, or CTEs for short. And common table expressions do exactly what subqueries does. However, the difference between common table expressions and subqueries is that common table expressions are temporal names, or you can give a temporal name to the query that you write. And this is a good practice because it improves readability, allows you to debug queries easier, and break down complex queries. So let's just demonstrate how a CTE would look like or be written. So we're going to name this table again summary table. So with summary underscore table as bracket open, I'm going to place all of this join we created, or this summary table we created, in here, and then after write my select statement. So select from summary table, and what I want from the table is a customer name and the order amount, sum of order amount. run this script, and we get the exact same results. So the difference is the structure of the query as against the structure of a subquery. So that's the difference between common table expression. The manner in which the queries are written, where you put your subqueries, and with common table expressions, you can give temporal names to these queries, such that when you run the queries by calling out the name in the from clause, you can easily pull out the columns. And this comes in handy when you're performing advanced analysis in SQL, right? So the next thing we are going to be looking at is views. So views works very similar to common table expressions and summary table. However, views allow you to create a virtual table, which is not temporal but permanent in your database. And if you look to the left hand side, it would fall under views once you create it. So let's just show how views look like. So start with create view. Let's name this view customer order table as, and I'm going to write a script for this, a join from joining the customer table, left join to the order sample table on a.customer id equals b.customer id. And what I want to see in the table is everything in the customer table and the order ID and the order amount as order amount. So if I'm to run just this query, it gives us a complete table showing everything in the customer table and data in the orders table, including the rows that exist in the orders, or customers that have placed orders against customer that has not. Right, so this is the view we want to create. So if I'm to run this entire script, click execute, command completed successfully, and what has happened is that a view has been created. And so we can call out that view now, and the view's name is what? Customer order table. So select all from customer order table, run that, and as you can see, we got the exact same results. Right, so that's how views work. And if I'm to refresh the dummy DB and click on views, you realize that the name of the table we just created now exists in the view folder on the left hand side. This can be deleted, but then what I want to add is that views create a permanent table in your database under the views column, right? So you need to be wary of whether to make use of views or subqueries depending on the best way you want to optimize your queries, reduce space, and if it is actually necessary to create a permanent table within the database, that's up to you. But it is a good practice to always optimize your queries so that they run faster. Yeah, and views, CTEs usually run faster, and views also come in handy. If, let's say, you want to visualize data in Power BI, views is a very good tool to make use of to create a table that has all the necessary columns that you need to perform your analysis in Power BI. So it's a good skill to have. So the next thing I want to show us is how to alter a view. Right? So alter view, and the view is customer order table. Put the name of the view there, customer as, you put the entire script there, and I want to add a condition where order amount is null. What I'm saying is I want to see the table for only customers that did not place an order. So I can run this query and it will show us customers that did not place an order. So therefore they don't have any order amount or order ID. When I run this, the view will be altered. And so therefore our customer table view will no longer have customers that have placed an order, as you can see there. So there you have it. That's how views work. That's how common table expressions work. That's how subqueries work in the select clause, in the select statements, the where clause, and the from clause. So we are going to be looking at Windows functions next. We are going to be looking at Windows functions. Now, some may be wondering, what is a Windows function? Windows function is the ability of SQL to allow you to perform calculations or aggregations on a row-by-row basis. It allows you to compare or make comparisons on a row-by-row basis without actually collapsing your database or summarizing it into a summary table. Now, in previous videos, we have spoken about and I've shown you how to make use of the group by function. In this video, we are going to be looking at the four main types or four main categories of Windows function, namely the aggregate Windows function, ranking functions, value offset functions, and distribution functions. So let's dive right in. Before we get to the first category, that's aggregate Windows function, it's important to understand the structure for the Windows functions. So we have the over, partition by, and order by. The over is a section or the syntax in SQL that tells SQL that this is a Windows function. And the partition by allows you to divide your rows according to specific segments or groups, right? And order by just defines the sorting arrangement in terms of ascending or descending order. Great. So you're going to be seeing these things a lot throughout the course of this video. So under aggregate Windows functions, we are able to perform aggregations such as the sum, average, count, min, and max. So I'll be demonstrating how we do that, starting with the sum function. So this is how the syntax is written. So I'm just going to take the sum function. Also, we will be making use of the online retail database. That is the database we'll be using for this video. Let me just copy that, bring that here. However, I want to narrow down the database to the country Canada. So I'll include a condition where country equals Canada. Okay, great. So now we are going to answer the question, or we are going to try and find the total quantity purchased for each item. So what we want to do first is to see the total quantity for each item on a row by row basis, side by side with the data that is already existing in the table. So this is how it will look. So I'm just going to put the sum here as a heading, and then we'll start writing our query. So I don't want to see all the columns. So I'm going to select the columns I want to see. What I want to see is stock code, description, and quantity. Right. So these are the three main columns I want to see. Now we are going to use the Windows function to create an additional column, and so we can add that here by including a comma that states that you're about to add a new column. Sum over order by. So this is the format it's going to take. So we have to fill in the gaps that are here. So what column do we want to sum? Is the quantity column, right? So we are going to put quantity in between the bracket, and we want to order by, again, let's say we want to order by the quantity column. Sorry. Put that right here, where country is Canada, right? So I forgot to mention that the partition by is not compulsory, it's optional. So with regards to the aggregation, we can take that out. And also when we get to the rankings function, we can take them out. I will demonstrate, but with this first example, I'm just going to make use of the order by and the sum. So let's run this query. Let's name this new column as QTY total. QTY. Great. So what we have now is a new column added to our data or our query that is summing up row by row the information in the quantity column. So as you can see, though, you will see that we have 2, then it moves on to 20. Then you see 47. And what is happening is for each time there is a duplicate, it represents the total value in the column, right? So the sum of 1 and 1 is 2. So that's the total, and the same total is repeated again. Once we sum 1, 1, and all these 2s, we are going to get 20, and that's what we see here. So we are going to cross-check that in Excel just to be sure. Let me get a new sheet, paste that here. So once I highlight all the 1s and 2s, as you can see, the total sum is 20. So that's how the sum function works. It works by aggregating the rows and giving you that information. So if we add the 3s, we are going to get 47 and the likes. So let me just highlight from 1 all the way to 3, and you see that the sum is currently 47. When I include the 4s, it will go to 91, and it goes on like that. So that's how the sum function works, right? And this is how to write the query for the sum function in terms of Windows function. It will come in handy when you want to analyze data on a row by row basis. Great. So we are moving on to average. Now the average works exactly the way the sum function does. All we're going to do is take out the sum and put the average or AVG. And we'll name this column AVG. Execute. And it's going to give us the average of the quantity column. And that average is being shown on a row by row basis as well. Great. So let's take this and cross-check it in Excel. So copy it, move to Excel, new worksheet. So once I sum all the 1s and 2s, I get an average of 1, right? If I sum the 3s as well, I get an average of 2.35. That is approximately 2, right? And if I go on to 4, the average is currently 2.95. That's 2. So that's how the average function works. It gives you the average of the quantity column, and that's what it does. So we've looked at sum and average. Now let's look at count. Count. So I'm going to select the same data, copy and paste it here, and change from AVG to count. Let's name this count of quantity count. run. And it's also counting the columns according to the number of rows. So we have 1 and 1, that's 2. Then we have 2, 2, 2, giving you 11 and the likes. Let's just cross check. I'll select the 1s and 2s, and you can see from the bottom that the count is 11, right? So that's what it's doing. It's counting the rows, and for every row that has a duplicate value, it's just going to give you the total count for that row. So that is how the aggregate windows function works. Finally, we are going to look at min and max. Min, and I'm going to take this and I'm going to change the count to min. So I want to count the quantity. I want to find out the minimum quantity, and instead of ordering by quantity, I'm going to order by stock code this time in descending order. Run. And what it has done is it has given us the minimum value. I forgot to rename this column, quantity minimum. So the minimum value is what is represented. If you check the results, I think 1 is the minimum value. So that's what we see. And max is vice versa. Execute. Execute, and there you have it. We have the maximum value represented there, and it keeps on adding on. So the sum function, it keeps on adding on. So each time, again, there are duplicate values, the same value remains. However, once you get to the second value, it keeps on adding on and the likes, just like that. Right, so that is it for the max. So max function works just like the minimum function. So we have the sum, the average, the count, the min, and the max. And these are the aggregations you can perform with the aggregate windows function. Next up, we'll be looking at ranking functions. Ranking functions are used to assign numerical values or numerical ranks to rows within a result set. They are essential for analytical queries, and they are usually used to categorize data in order. Let's say an example is the leadership boards, or top 10 or top n. So when you want to, let's say, rank your data or rank the values in your rows according to from highest to lowest, or let's say find the top values per a specific column, ranking comes in handy. So we are going to start by looking at row number and what row number does, right? So row number's key characteristics is that it generates a unique value for each and every single row in your database, or each and every single row in the data. So let me just demonstrate how row number works. So let me just select from online retail. Let's say I want to select customer ID and then row number over partition by customer ID. Let's order by customer ID too. And where country equals Canada. Let's run this. Let's name this as row num. This our new column. And then looking at our results, you can see that a value has been assigned to each and every single row that has a customer ID. And the moment a new ID starts, the numbering or ranking begins. And that's because we chose customer ID as the column for the demonstration purpose. So let's say if it was a quantity column, the quantity column would also be ranked according to the values, and then we can also group that by customer ID or not. All right, so let me just test with that. Quantity. Now, in fact, let me just take out this part, so there'll be no partition. Order by quantity. Yeah, so that's how the row number function works and the ranking. And let's say perhaps I want to find rows that have duplicates based on a specific column. So let's say in this instance, I want to find duplicates that exist in our database, right? Select all from online retail, right? And then so when I select the entire database, because it consists of transactions, there are definitely going to be some repeated or duplicates, or some columns are going to have repeated unique IDs and such. So let's say perhaps there's a column that I want to take out all duplicates, and let's say it's the customer ID column. I'm going to build on this query. So let's make use of a CTE. So I'm going to highlight this query and state this with row number table as, then I'll paste what we just did in the bracket. Select all, or select star. Star means all, from row number table. And then I'll add a condition this time, where row num that's the new column we created is greater than 1. Let me run this and see. I forgot to name this as row num. So copy this, paste it here. Right, so I was calling a column name that didn't exist, but now it does. So I'm going to run it. And there you have it. So basically what I'm telling SQL to do is to give me all values where the customer ID appeared more than once. And in this instance, it shows through the row number column for any value which is greater than 1. Right. So it's another use case of ranking functions is for the identification of duplicates, for deduplication, and also for sequential numbering. So that's it for the row number function. So now we are going to learn how to make use of the rank function. So with rank allows you to provide a sequence of numbers, right? It allows you to provide a sequence of numbers. However, it skips numbers if there is a tie. An example is once you notice a value appearing twice, like the customer ID appearing twice, instead of the rank function to number accordingly as 1, 2, 3, because they are the same value, it's going to assign 1 to each value. So it's going to be 1, 1, 1, 1, 1 up until the next customer ID or the next value, which is different. And what it's going to do is not going to go to 2, but it's going to go to the count that represents that position. So let me just demonstrate how the rank function works. Select okay, before I jump into this, let me just create a view so my queries don't look too complicated. So let me just create view. So create view, row table as so I've created a view, and if you want to know what a view is, you can watch my previous video. However, it's a virtual table that has been created that can easily be pulled out of the database. So when we check from the online DB under tables and the views, the view that we created would exist, and we named this view row table. So we're expecting to see row table right here, right? So now I can easily just type select all from row table and pull out the information on row number as I did, right? Great. So now for rank, since I've now created a view, let's give an example of the rank statement. So I'm going to do select all from row table in this instance. In fact, I just need the customer ID. So let me just say select customer ID from row table, rank, or rank doesn't, it's not case sensitive, so rank over order by customer ID as row just to make it as simple as possible. Great. And in looking at this, it shows exactly what I was trying to describe, because the value in the customer ID column that we're trying to rank has replications. It represents every tie or every replication as a single rank. The moment that replication changes, it then goes to the next rank, which serves as the count of the position that it is. So you can see that the rank, the customer ID 17443 falls at the 11th position, and that's where the row number rank had counted up to. So it moves to 11. When the customer ID changed to 17444, it also changed. And it goes on like that. It goes on like that. So that's how rank works. And its main characteristics is that it skips the next row after a tie. The next thing we're going to be looking at is dense rank. I'm just going to copy this and paste it here. And the major difference between rank and dense rank is that dense rank does not skip a step. Dense rank does not skip steps when they are ties, After the tie, it's going to go through to the next continue ranking. So let me just run this. Let's name it dense rank. Okay, so even though wherever the value repeated itself, it showed as 1. When I moved on to the second value, the rank went to 2. It didn't go to 11, right? When it went to the third value, it went to 3 and not 12. So this is how the dense rank works, right? And finally, we'll be looking at the entile function. Now, the entile function is used for grouping data by adding or laying down the numbers of groups you want. So let's say I want to group these custom IDs, these 151 custom IDs. I want to divide them into groups. With the entile, you state the number of groups that you want, and then it will create a column dividing them into groups. So then let's just look at how the entile function works. Great. So again, I'm going to select this, copy, paste it here, and then change this to entile. Entile. And I want to create 5 groups. And then I'm naming it entile grouping. Run. And now the entire data set has been grouped into 5. So in the entire column, you see 1, 2, 3, 4, and 5. So these are the main groupings that has been created with the entile function, and so that's what it's used for. So these are the 4 main ranking functions, and they come in handy a lot as you continue to query data, analyze data, and try to break down your analysis on a row by row basis. The next category we are going to look at, the next category of Windows function we'll be looking at, is the value offset function. And this also consists of 4 main types. We have a lag, lead, first value, and lag and last value. And they answer questions like, what was the previous value? What is the next value? What was the first value in this group, and what was the last? So the lag function allows you to compare a column of data to previous data in that same column, right? Whereas lead allows you to compare rows to future rows or to the next row. So let me just demonstrate. So with the lag function, I'm going to write a statement, select all from online retail, and in this time we don't have a total sale column. Let me just run this first. Looking at the data set, we do not have a total sale column, but I want to use a total sale column for this video, for this demonstration. So I'm going to add that as units price times, asterisk also means times, depending on how you use it. Units price times quantity. Put it in brackets. And we'll name this new column total sale. Right. Right. And using this, I want to be able to compare the total sales of the previous rows to that of the next row. So in order to do that, I can create another view or use a CTE. Let me just use a CTE for this first. Name it with new table. I'm going to name the table new table. as this. Select from new table. Great. So I don't want to select everything, so I'm going to select total sale, and then write a lag function. So lag is written this way: lag total sale. That's the column that I want to compare over order by total sale as previous sale. And looking at this, you would realize that the values that have been generated, looking at the total sale column, you can see negative 168,469.6. And then because we compare it to previous sale and there is no previous sale, the first column is going to be null. However, you realize that the total sale is brought down here, comparing against this row. And the next row is comparing against the previous row. That was -7, which is moved here. Same with this one being compared with that, and the likes. So if, let's say, we didn't want to compare total sale but quantity, we could do that too. Let me just replace this with quantity. And the same applies. Yeah, I forgot to add, let's say, narrowing down my search where country equals Canada. So where country equals Canada, it's always going to be previous quantity as against new quantity or total sale. Great. So this is me just testing to ensure that it works. So this is how the lag function works. It compares the previous row to the current row. Now we are going to look at lead. And lead does the exact same thing lag does. However, it doesn't look at the previous row. It looks at the next or incoming row. So I'm going to copy what we've done and paste it here. And then change the lag to lead. Let's name it next row. Run. Right. Now looking at the total sale column, you can see that the first value is 2.5. However, the next value is 4.68, and that's what is being compared against. Similarly, when we look at 5.04, it's being compared to 6.64, which is the next value. So that is exactly how the lead function works. The next thing we'll look at is the first value function. And what the first value function does is that it shows you the first value within the total sales column, right? So it gives you the top row or the first value in the column. And then the last value also gives you the last value in the column. So if I copy and paste this here and change this to first value, as first, and run, the first value in the total sales column is 2.5, and that value has been represented throughout the entire table. And then if, let's say, we want to represent the last value, we will also do that. However, with the last value, we'll have to select or create or include a range for SQL to pull from. So I'll add that here in the order by clause, where rows is between, unbounded preceding. And unbounded following. Oh, sorry, too many E's. Great. So the last value in the total sales is 550. I mean, you can also get, you can create the both columns. Let's say you want to see the first value and the last value. It's possible to do that as well. Let me run this and see what happens. And I should have named this last, but you get the drift. So basically, I've been able to pull out the total sale column, the first value from the total sale, and the last value. So that's it for the value offset functions. We have the lag, lead, first value, and last value. Now finally, we are going to be looking at distribution functions. So distribution functions allow you to compare rows against an entire data set. An example is, if you select row A, cell A, what percentage of it compared to the entire data set? So we have two main types of distribution functions, namely the percent rank and the cum dist, or cumulative distribution. So I'll just demonstrate how they both work. Starting with the percent rank. So first, I want to create a view, a different view. So let's create a summary table. Create view summary table as, select again from online DB, and this time I want to create a group by function where I sum up quantity as sum of QTY, right? And add the group by country. So I'm going to create this view called summary table. Execute. So I already have a table named summary table. Let me name it summary tables with a Z. Great. And I'm going to be using this to demonstrate how the percent rank and cum dist functions work. So let's select all from summary table Z, Execute. This table gives us the countries in the online DB and then the sum of the quantity. And now we are going to add a column called, by writing the function %rank over order by as %rank. Now looking at our values, we see that in the %rank column, all the values that show are between 0 and 1. And that's exactly how the %rank function works. It gives you a number between 0 and 1, where 0 is the least and 1 is the most, or 1 can be seen as 100% or the largest value within a database. It's actually used to identify the top 10 of a table or top 10 of a column based on the column, right? So example, 0.025 means that this value falls in the bottom of the countries, whereas 1 means that this value serves as the majority of the data set or has the largest value based on the column that we gave it. Do you get it? That's the sum of quantity. So that's how the % or rank function works. And now let's demonstrate how the cumulative dist function also works. Let me just copy and paste this query. Change this. Oh, sorry, I forgot to add the E. And the cumulative distribution function also works similar to the %rank function. However, it returns or gives a cumulative distribution of the portion of rows that are less than or equal to the current row. So it gives a more accurate picture of the bottom values of a table. Example, where you can see that this is the 0.25, whereas which can be seen as, let's say, 25% or less than 25% of the sales. Whereas the %rank gives a clearer picture of the values within a column that are on the higher spectrum, or the top values within a column. So this is how the cumulative function works. And perhaps if you don't want to see it in decimals, you can easily multiply it by 100 and it will give you the same results, right? So today we have been able to learn about Windows function, and specifically the 4 main types of Windows function: the aggregate Windows function, the ranking functions, the value offset functions, and the distribution function. And I must say that this is a must to know for senior SQL roles or SQL employees to know, because it comes very handy when you are analyzing data in SQL, and it helps you to delve deeper into analysis on a row level and allows you to easily compare data. Each of them have very unique functions and they are very essential to know. Okay, so that's all for this video. Thank you very much for watching. Like and subscribe.